Good afternoon. Welcome back to Mr. Reed Math, where we're going to take some of the mystery in math and make it past tense. And this is a special video made just for my 6th period class because I'm in training today, having a great time, I promise you. And I wanted to leave a little bit of an extension from our lesson yesterday where we talked about identifying the slopes of parallel and perpendicular lines and continue on into a lesson on writing equations for parallel and perpendicular lines. So without further ado, let's begin by talking a little bit about the bell ringer. And hopefully when you all came in, you saw that the example on the left was for tables 5 and 6. The example in the middle was for table groups 3 and 4. And the example on the right was for table groups 1 and 2. And what you were supposed to do is look at those pairs of points or coordinates and figure out what is the line drawn between them. And then compare the slopes of those two lines and find out if that relationship was either parallel, perpendicular, or just something else. All right, so with special regard to number 3 and 4, if you look at line number 1, you should have come up with a slope of 3. And line number 2, you should have come up with a slope of -3. And when you look at that, well, let me see, what happened? So from 3 to -3, it's definitely not parallel because those are different slopes. But is it perpendicular? Well, let me see. Perpendicular, you're supposed to switch the sign, which that certainly happened, from 3 to -3. But you're also supposed to flip the fraction. And that would mean taking 3 over 1 and turn it into 1 over 3. All right, so because both of them were just left as 3 over 1, no, it's not perpendicular at all. It's just another intersection. It doesn't qualify as either parallel or perpendicular, so therefore it's neither. All right, switch with no flip. Sad. Okay, now let's move on. Now, if you remember, yesterday we spoke specifically about, there were two of the things that I wanted you to remember. And when you're writing a line that's supposed to be parallel to another one, you want to make sure that you copy the slope. All right, as long as you do that, your line is going to be parallel. No matter if you're way to the left, way to the right, or somewhere else located, if the slopes are the same, the lines are parallel. All right, perpendicular, we also talked about where, just like that little Harry Potter example that I gave you, where it's not a swish and a flick, it's a switch and a flip. Okay, you switch the sign either from positive to negative or negative to positive, and you flip the fraction. If it's a whole number and you just see the one number, well, just keep in mind there's a 1 underneath that whole number that you can bring in and you can flip the fraction. Okay, so for example, 2/3, you would switch the sign to -2/3, and then you would flip the fraction from -2/3 to -3 over 2. All right, now let me get some paper out and just start writing and illustrating here, so maybe you're seeing something that goes along with my words. Now, let's start learning how to write equations, shall we? Okay, so I'd say probably every question you get on this topic is going to tell you you need to put it into slope-intercept form. Right? And if you recall, slope-intercept form is simply y equals mx plus b. Okay. You're going to leave the y alone. That's the variable. You're going to leave the x alone. That's also a variable. Input variable, output variable. Dependent variable, independent variable. However you want to think of it. All right. But you're just going to leave x and y alone. And m is the slope and b is the y-intercept. So you have to find those two things when you write this equation. Otherwise, it's not complete. All right, for each question that you're given in this style, you're going to be given a comparison line. All right, and just to kind of scribble some things on the page, to give you an idea, you're going to be given a line that, okay, goes like this. All right, that would be a line if this is the x-axis, this is the y-axis, that would be a line with a positive slope. Okay, let's just call it like a, I don't know, positive 3/4 slope. Okay, and then you're going to be told either to draw a line that's parallel or perpendicular to this line, just like we've already kind of sort of prepped in class. All right. Not only that, you're going to be told to draw that line through a specific point so that there's only one possible answer you can give. All right. So you'll be given a coordinate like, I don't know, let's say 4, 5. Okay. And then you'll be told, okay, let's draw a parallel line. Well, if it's a parallel line, then 3/4 slope, you're going to copy that slope. You're going to draw another line with 3/4 slope that goes through it. If it's a perpendicular line, you're going to switch the sign. This is positive. You're going to switch to negative, and then you're going to flip the fraction to 4 over 3. So -4/3. And then you'll draw that perpendicular line straight down through here. All right, so step 1 is determine the slope of the comparison line. Okay, and you might only be given 2 points, kind of like what was on the board for the bell ringer. And you've got to use the slope formula and figure out what the slope is. All right, now, my advice to you is once you figure out the slope of the line, you don't need that line for anything else. That's it. That's all you need it for, is to figure out the slope. All right, and then you're going to move on to step 2. So put that line out of mind, because you don't want to confuse it. You want to focus on the line you're getting ready to draw. And you want to remember what slope that line needs to be. Let's say that we're doing an example that's perpendicular. Okay, so I take the slope from this line and I switch the sign and I flip the fraction to 4/3. Okay, so now I'm going to make a note of that somewhere in a different location probably and say, okay, m equals negative 4/3. Perfect. All right, and then I want to know, where do I need to go? Where does this line need to go through? And if you saw before, I've got a point 4, 5. Okay, so 4, 5. All right, and this is the x value, this is the y value. More importantly, that's the x1 value and the y1 value. Okay, so the x1 is 4, the y1 is 5. Cool. Actually, I'm just kind of building up to let's go ahead and do an example. Now, it says in the instructions perpendicular, but I'm not really worried about that anymore because I've figured out what the slope of my line is going to be. I already know it's going to be perpendicular because I've got a perpendicular slope, and now I've got references to the point that I'm going to go through. So now I just need to come up with the equation of the line. Well, I know it's going to be y equals negative 4/3 x, and then there's going to be a y-intercept, and that's really the only thing I'm looking for now. Well, the easiest way to get through this, so once I figured out what the slope was of the comparison line, and then I figure out what my slope needs to be, and then I figure out, what my point is, well, now I'm just going to write and convert my line into y equals mx plus b, okay? Now, you can also use the y not max your time mode that I showed you the other day. That's fine. That's up to you. At this point, this is when you would do that because you're just trying to get what the intercept is. But I'm going to go ahead and use the point slope. So if you recall, point slope is y minus y1 equals m times x minus x1. Okay, so I'm just going to take this data and plug it in to what I know from here. So y minus 5 equals negative 4/3 times x minus 4. Okay, and as soon as I get that converted to slope intercept, I'm done. Okay, so let's go ahead and do the conversion. The first thing you do is you distribute. I'm going to rewrite y minus 5, and I'm going to distribute negative 4/3 into multiplying it by each term within that parenthesis. So negative 4/3 x is as far as I can take that one. Okay, and then negative 4/3 times negative 4. Well, it's going to be a positive number because it's negative times a negative. And then I've got 16 over 3. Okay, because it's basically 4 over 3 times 4 over 1. All right, cool. So now I have distributed, and now I want to take and I want to isolate the y. So I've got it in that y equals mx plus b format. All right, so I'm going to add 5, and I'm going to add 5. Except here, when I say add 5, I want it to be in terms of something with a 3 in the denominator. So I'm going to say I'm going to add 15 over 3, because that's the same as 5. All right, I multiplied the top and the bottom by 3. Cool. All right, so now I'm going to rewrite y equals negative 4/3 x plus 16 over 3 plus 15 over 3. And if you notice, this part right here already looks exactly like that part. I'm closing out here. I'm locked in. All I'm doing is I'm trying to figure out what that y-intercept is. Okay? And when I add those two numbers together, be careful with your negatives. In this case, it's just positives. So 16 plus 15 is 31. So plus 31 over 3. And at this point, I would leave it as an improper fraction. Okay? If you have it as a decimal, I'll accept that as long as it's correct. But let's get into this habit. Okay? All right, so that's the concept of today. You've got a worksheet to work on. It's got 8 examples, 4 of them for parallel lines, 4 of them for perpendicular lines. Get some practice, get some reps on this, and I hope you all have a great day. I will see you tomorrow, and we will continue this. All right? Bye-bye.